Okay, this last part with proportions deals with similar figures but involved in word problems. And these are probably the most common that you see on standardized tests. It usually has to do with shadows and things of that nature. So, one thing I think that helps in geometry, anything involving geometry problems, is trying to draw a picture. So, for most of these, I'm going to try to set up some sort of picture to kind of help you visualize what's going on. Now, the thing you're going to have to do is you're going to have to, in many cases, try to translate the information. So I'm going to erase all this stuff right now, and I'll come back to those here in a minute. So let's take this first one. So here's what we're talking about with a shadow, a 16-foot tall adult giraffe. So I'm just going to draw a janky looking giraffe here. Okay, there's a great giraffe, right? Okay. Cast a shadow that's 4 feet long. So the giraffe's 16 feet. There's the shadow of the giraffe that's 4 feet. Okay, not to scale. Then how long is the shadow that a 4 foot tall petrified stump? So here's the stump that's 4 feet tall. How long is its shadow? Okay, so that's being a little bit more literal with the pictures. In actuality, what I always do is I just draw a triangle. There's the giraffe, 16 feet. There's the shadow it casts, 4 feet. There's my triangle. So then I have a stump that's 4 feet. How long is its shadow? There's a triangle. So these are similar figures, and there's the shadow I'm looking for. So what we just did in a previous lesson applies here. So I set up my proportion, big, 16, over small, 4, equals big, 4, over small, x, what I'm looking for. Cross multiply, 16x, 4 times 4 is 16, divide by 16, you're going to get x is 1. So it casts a 1 foot shadow. Make sure you put your units there. Okay. Now, not everything is going to be similar figures. Sometimes it's just a proportional relationship. So here is one that talks about a model car. Okay, so whenever you look at model cars or model anything, there's always a scale factor. This is our scale factor. 3 inches is 6 feet. Okay, so I'm going to write that as a fraction, but I'm also going to include the units. The reason is when I set up my proportion, my units need to be the same. In other words, this says 12 feet. Well, I know that has to go on the bottom. Why? Because feet is on the bottom here, feet have to go on the bottom there. So I'm looking to see how long my model is. So x, and it'll be in inches. So cross multiply, 6x, 12 times 3 is 36, divide by 6, and we get x is 6. And then again, remember our units here are inches. Alright, the next one. San Jose and Madison are 24.1 miles from each other. How far apart would the cities be on a map? So here's another scale. Scale 1.1 inches to 10.2 miles. 1.1 inch, 10.2 miles equals what I know, 24.1, and that's in miles, so that's got to go on the bottom. So I'm looking for how many inches it would be on the map. So cross multiply, 10.2x equals, so I get my calculator out, so 24.1 times 1.1 is 26.51. You're going to divide by 10.2, and then x would be, so divide by 10.2, 5, 2 point, it says 10 nearest 10th, it gets 2.599, so that would round up to 2.6, and again my units are in inches for this problem. So hopefully these are making sense to you here a little bit. I want to continue on. So this one says round to the nearest whole number. Okay, whole number. That means whatever my first decimal is will determine whether or not I round it up or not. So again, we have a map. So we have a scale, 1 centimeter. Oops, sorry about that. 1 centimeter is 14 kilometers. We have 6 centimeters. We want to know how far apart are the two cities for real, so x kilometers. So that's just going to be x is 6 times 14 is 84. So it would be 84 kilometers. Okay, a lawn ornament that is 2 feet tall casts a shadow. So here's a shadow problem again. So here we're going to use triangles. A lawn ornament casts a shadow, so 2 feet, casts a shadow 5 feet. Find the length of the shadow at a 6-foot woman. So we got a taller woman. That means her shadow is going to be longer. So 6-foot tall woman, how long's her shadow? So then we do 2 over 6 has to equal 5 over x. Cross multiply. 2x equals 30. Divide by 2. And we get x is 15. Remember our units, 15-foot shadow. Alright, almost done here. Find the distance between Rivertown and Salem. Okay, this one says to the nearest tenth. So we've got another scale again. So we write our scale down. 1.6 centimeters, 6.1 kilometers. We have 4.6 kilometers, so that has to go on the bottom with the other kilometers. We're looking for how many centimeters they would be on the map. So cross multiply, so 6.1x equals, get my calculator out, 0.6 times 4.6 be 7.36, divide by 6.1. So divide that by 6.1 and we get x is 1.2 to the nearest tenth, and again my units here are centimeters on top. So drawing a picture for some if it's applicable, but then sometimes it's just a scale factor on a map and then you set up your proportion.